Hello students, in our today's lecture we are starting our unit number 2 of the statistics. Chapter name is differentiation. The whole unit is only a differentiation, out of which the 25% marks will be there in your examination. That means 17 marks are covered in only this one chapter, right? So let's start with the differentiation. First we are starting what is the differentiation. We have studied already the function and the limit of the function. Now we are studying the differentiation. Whenever we put in the function the value of x and we added some extra value to it, just like h, right? And after finding that limit of that function of the format, we have to put a particular function into this format where x is equals to a, x is equals to a means any value of x, any value 1, 2, 3, 4, it can be anything, right? So when we put the function in the format of this after adding h to the function, h is also here, it's some function, some value would be there or h. So whenever we add the h to the function and put it into this format, f a plus h minus f of a upon h, and after finding its limit h tends to 0, where the f of x a plus h minus f a upon h, and the value we are derived from it after applying the limit of the function. Whatever we answer get, this is known as derivative of the function. Are you getting me? Whenever we apply the limit of the function after adding h to the function and put it into the format of this fixed format, whatever answer will come, that answer is known as derivative of the function, denoted by the f dash a and dy by dx, right? This is known as derivative of the function. And in the process of the obtaining the derivative of the function, the whole process known as differentiation. Are you getting me? Whenever whole process known as differentiation, right, and that answer came after the solution of that limit f a plus h minus f a upon h, known as derivative of the function, right? You get easily understand when we start our illustrations. Let's understand with one illustration. Find the derivative of the x square from definition. Whenever it's written from definition, you have to apply the function in this format and you have to find out the derivative, right? So whenever it's written from definition, you have to apply that function specific format. So f of x, x square, find the derivative of the x square from the definition. The function is x square, and now we have to put the x is equals to x plus h. So instead of x we put x of h whole square, that a plus b whole square, we get a square plus 2ab plus b square. So what would be the answer? X square plus 2xh plus h square, right? Both we have fx and fx plus h. Now we are putting this function. Function is equals to x square, fx plus h is whole square is equals to x square plus 2xh plus h square. Now we are putting this specific format. So limit x tends to 0, fx plus h minus fx upon h. So what would be the value of the x plus h? The value is x square plus 2xh plus h square. minus f of x is h square upon h, right? X square get cancelled. We get 2xh plus h square upon h, right? We common the h, so we get h 2x plus h upon h. H get cancelled. We get 2x plus h. Limit h tends to 0. We know after the cancelling the element we have to apply the value of h. So value of h would be 0. So 2x plus 0. We get the answer 2x. Right? So dy by dx of x square is equals to 2x. Right? In the earlier limit function we have to limit of the x. In the limit function we have to write like this, limit x tends to 1, 2, 3 anything. But here the h tends to some specific value. Right? And we have to find out by dy by dx. So x squares dy by dx is equals to 2x. That is a differentiation. In such a way we can find out the differentiation of the x also, x cube also, or any x raised to n. Sometime it will ask in the examination that obtain the derivative of the x raised to n using the definitions, right? So under root x, 1 by x, any kind of a differentiation using the definition or applying the same rules of the limit we have done, right? We obtain the dy by dx, right? Let's start with the illustration number 1. Illustration number 1. What is the illustration number 1? Find the derivative of the following function using the definition. So, using the definition, first function is f of x is equals to 2x plus 3. Right? Now we have to find out the f x plus h. So, in x we have to put x plus h. So, 2x plus h plus 3. Multiply with 2x plus 2h plus 3. Right? The format would be limit h tends to 0 f x plus h minus f x upon h. 2x plus 2h plus 3 value of f of xh minus f of x in a bracket 2x plus 3, always write in a bracket upon h. So 2x plus 2h plus 3 minus 2x plus minus 3 upon h. Plus 3 minus 3 get cancelled. 2x plus 2x minus get cancelled. We have only 2h upon h. H get cancelled. We get the value of 2. That is a dy by dx. Differentiation of the function 2x plus 3 is equals to 2. Simple enough? Now, illustration 1's second. 4x square plus 5x plus 1. Function is equals to 4x square plus 5x plus 1. Now we have to find out the f x plus h. So whenever x is there we have to put x plus h. Sorry. So 4x plus h whole square plus 5x plus h plus 1. So what is the factorization of the x plus h square, it will come x square plus 2xh plus h square plus 5x plus 5h plus 1. Again the multiplication it will be there. So 4x square plus 8xh plus 4h square plus 5x plus 5h plus 1. Now we are putting the format limit h tends to 0 fx plus h minus fx upon h. The value of f x plus h is this. So 4x square plus 8xh plus 4h square plus 5x plus 5h plus 1 minus in a bracket 4x square plus 5x plus 1 upon h. After the bracket opening, what we get? 4x square plus 8xh4x square cut, 5x cut, plus 1 minus 1 cut. We get 8xh plus 4h square plus 5h upon h. We common the h, so h will get common. 8x plus 4h plus 5 upon h. H get cancelled, and we put the limit h tends to 0. We get x 8h plus 4h plus 5. We are putting h is equals to 0. So xh plus 40 plus 5. We get 8x plus 5. So dy by dx is equals to 8x plus 5. Got it? The rest of 2, 3x square and 5x minus 9, you have to do in your homework, right? We can find out the derivative or differentiation using that definition, but some of the rules are there, so we can directly identify the differentiation, or we can solve the differentiation using that rules. So let's start some basic rules that are required in further chapter, right? So rule number 1, or some important principle will be there. So if y is equals to x raised to n, when function is given x raised to n, so direct we can differentiation like this: dy by dx is equals to n into x n minus 1. Whenever the x raised to n is given, you can directly differentiate the n into x raised to n minus 1 using that rule. I show you one example. Suppose x square is there. X square is there. So using that y is equals to x square, then dy by dx would be 2 is the n. So n will come this side into x n minus 1. So 2 minus 1, it will 1. So we can write 2x. So directly dy by dx we can find out the 2x. In earlier, after using that differentiation of the derivative of the function x square, we have to make a whole process and then we get the answer of the 2x, right? But using that simple rule, we can directly find out the differentiation just like 2x. The function is same. Function is x square. Here also function is same. y is equals to x square. So using that definition we have to make some long process and then we get the answer. But using that simple rule we can directly find out the answer or a differentiation. Let's try some other example. Y is equals to 3x square. So here n is equals to 2. When this is come in the multiplication of the 3, when it's come this side, so 3 into 2 x, 2 minus 1 1, 3 2s are 6x. So what would be the dy by dx? 3x square dy by dx will be 6x using that rule, n into x raised to n minus 1, right? You can solve the any x square or any x raised to n is given, you can directly apply this rule. No need to go through the definition method, right? You can directly use this rule. There is the rule number 1. Let's start rule number 2. You have to write down all the rules in your notebooks. Rule number 2. Y is equals to Ex, then differentiation of dy by dx will be same. There is no change. Whenever e raised to x is given, the dy by dx will not change. It will remain same. Then rule number 3. Y is equals to log ex. Then dy by dx will be 1 by x. So log e raised to x, always remember these rules. Whenever e raised to x is given, you have to differentiate with the same. It will not change. Whenever log ex given, the dy by dx is equals to 1 by x. And now rule number 4. A raised to x. A raised to x, that means any number in a power of x. X raised to square is not like this. Whenever 2 raised to x is given, when x in a power, whenever x in a power, you have to use these rules. So dy by dx is equals to ax into log ea. Use 3 basic 4 differentiation rules and you have to remember these rules. 1, 2, 3, 4, all of them. Now basic another rules are coming. Any function of where u and v are there, right? So in the addition, subtraction, multiplication and the division, the 3 rules are applied. Let's write down all the rules. When y is equals to u plus v, whenever the function is a 2 element were there and the addition in between this, right? So you have to find out the rule of the addition. Rule number 1. dy by dx is equals to du upon dx plus dv upon dx. Then individually you have to find out the u's differentiation and v's differentiation. That is a rule number 1. Then rule number 2. Y is equals to u minus v. Then dy by dx is equals to du upon dx minus dv upon dx. Then rule number 3. When there is a multiplication, here is the addition, subtraction, now multiplication, u into v. Then rule will be dy by dx is equals to u into dv upon dx plus v into u upon dx. So here is a u is there, so in differentiation of the v, multiply with that, and here is the v, and the differentiation of the u will be in multiplication. So u into dv upon dx plus v into du upon dx. Now rule number 4. It is in a division, so y is equals to u upon v. So dy by dx is equals to v into du upon dx minus u into dv upon dx whole v square. You might not understand this kind of a rule, but whenever we apply in the sum, you can easily understood this, right? So don't confuse in that, just write down and try to remember the rules. And using that all rule, we can solve the many illustration and sum also in our next lecture. So try to remember this rules and write down in your notebook. Thank you.